I'll let you guys do the majority of the work, yeah. So let's look at the packet tracer file. Okay, so this is the file. So you can see, try to have a look at the topology first. Okay, as you can see, we have two LANs, yeah. Okay, separated by the first one is router 0, then the other one is router 1, right? And then we can see there's a serial line connecting the two LANs together to form a wide area network. Okay, so let's have a look at the node itself. Right, so usually when the packet tracer activity files provide you with the address file here, okay, first table here, you can see, right? So this will indicate to you the configuration of the addresses. In this case, we are looking at the ARP table, yeah, address resolution protocol table, yeah. Okay, so we know this ARP works in a LAN, and it works, so that means LANs uses the MAC addresses, yeah, for communication. So that's why we see that the focus here is the MAC addresses. Right, so just a quick recap on ARP. We have covered this in the lecture earlier on. So ARP is used to resolve the IP address, which is address on the network layer. Okay, so resolve the IP address to MAC address. Okay, what does it mean by resolving these two address? Is that imagine that this inside the LAN, the sender wants to send a message to another host. Yeah? Okay, so usually when we're at the application level, every time we want to communicate between our own device to another device, the minimum we need to have is the IP address of the destination computer, right? Destination host. Okay, right. This is what we're used to because we know IP address represent a unique address of individual hosts, right? So in the situation where our device has the destination device IP address, but we don't have the MAC address. Now, the problem is inside our own LAN, okay, it's not the IP address that's being used to forward our message. Okay, in our LAN, the address that's being used by our intermediate device, which is a switch, will be the MAC address. Okay, the switch will use the MAC address to perform switching, to create a virtual circuit between two hosts within a LAN. Okay, so you can see here that imagine that this is a LAN. Okay, so the device wanting to communicate to any other end devices within the same local area network will not only need the IP address, okay, but also the MAC address. So the part of the MAC address, how does the sender get the MAC address, right? Is that through using a protocol called ARP. Okay, so there will be an ARP request, okay, sent out, right? So since the original sender does not know what is the destination MAC address, there's no this option to it rather than putting a broadcast address for the ARP message. Okay, remember the broadcast message. later we'll discover this. What is the broadcast message address? What is address for broadcast? Remember, broadcast is one to all. Okay, so unicast is one to one. We want to perform unicast, but we don't know the destination MAC address, so we use ARP, okay, to request for the destination's MAC address. Since we don't know, so we have to do broadcast. So broadcast is one to all. So all machines within the LAN will receive the ARP request. Okay, but only the machine with the correct IP address will actually pick up the ARP request and perform an ARP reply. Okay, so once the original sender receives the ARP reply, it will have the sender's MAC address, and therefore it can then use that MAC address to use as destination MAC address for the original message you want to send. All right. So in this exercise, okay, we were going to simulate that situation. Okay. So if you look at the objective, okay, we want to examine an ARP request. Okay, and then we want to examine a switch MAC address table. Okay, remember that a switch can perform based on the incoming frame. The switch can perform any of two things. Either the switch will use the incoming frame for learning, because the switch have to create or to dynamically populate the MAC address table, or a switch can do forwarding, or maybe both at the same time. So when the switch see that there's an incoming frame, okay, incoming or inbound frame, switch sees an inbound frame, it will, if it checks the source address, means what does it mean? The switch wants to update its MAC address table. How? Because the source MAC address for an inbound frame allows the switch to know for that particular port, okay, for that particular port for the inbound frame, it can then know, okay, so which computer with that particular source MAC address, okay, so that it can update its MAC address table. Okay. The forwarding aspect means the switch have to look at the other MAC address, the destination MAC address. Okay, so the switch look at the source address in order to update its MAC address table. The MAC address table, as we know, map ports, okay, the switch ports against MAC address, right? So the switch will use its MAC address table so that it knows how to forward a frame. Okay, it looks at inbound frame's destination address, MAC address, destination address, compare it, compare it against the entries within the MAC address table. If it finds a match, right, the switch will then look at the equivalent port address. Okay, it finds a match, checks out the port address, okay, and then forward it through that port. Okay, if it didn't find the matching, okay, entry, so the switch has no option but to forward that frame to all ports. Okay, so these are the two things that the switch do, okay, in terms of learning about the source address so that it can dynamically update its MAC address table, and also forwarding frames based on the MAC address table. So in part 2, okay, we're going to examine this switch MAC address table. So the MAC address table basically is a table that maps port against MAC address against port. Okay, right? And then we know that ARP is supposed to work within LAN. But what if the host within the LAN wants to communicate with a remote host? And if the host wants to communicate with a remote host, we know, okay, let's say any of these hosts here want to communicate with any of these hosts here. So that means it's remote because it goes beyond their own gateway, right? So in terms of ARP, how does ARP helps this host to achieve that? Okay, so this is the objective of part 3. Examine the ARP process in remote communications. So the 3 parts here, and if you get or understand these 3 parts, how exactly it works, then you understand local area networking quite well. Okay, right? Okay, so again, very similar to yesterday, this activity is optimized for viewing PDUs. That means it's geared towards you understanding the packet data, protocol data units in order to understand the movement of these PDUs for the purpose of understanding ARP. So all these devices are already configured, means they're already configured with these MAC addresses. Okay, what you do is you go to simulation mode, okay, to basically perform a series of actions that allow you to capture PDUs, okay, and at each specific point during the ARP processor, you can view those PDUs, and also because of that, you'll be able to answer a series of questions, okay, that the activity will ask you. Okay, let's go and look at part 1. Examine an ARP request. Okay, so please open this packet trace activity and follow together with me. As I said before, I will not go back to cover everything. I just want to start you off, and then you will do the necessary the rest, and also do the answers, answer your questions in a separate Word document for your own keeping. Yeah, right. So there's a new command here that you need to perform. ARP we already did earlier on, but the command we did during the lecture is ARP-A. Okay, ARP-A basically allows you to view the content of the ARP table within your computer. So remember, so if I just open up this command prompt for you. Okay, there's a command prompt in Windows. If you type ARP, just ARP, so far the command -A is to display, right? To display. So we can the computer will display the ARP table for you, the content of it, right? So again, ARP table is maintained dynamically by your system, huh? Right. So what we want to utilize today is -D. -D indicates that you're asking the ARP to empty out its ARP table. So basically deletes, okay, deletes the ARP table, the content of the ARP table. Okay, so that's what we want. Why do we want to do this? Because we want to simulate the fact that the computer has to send out an ARP request, and this only happens if there's no matches in its ARP table between the IP address and the MAC address. Okay. Right. If you have any questions, you can ask me directly. This concept is quite important to get around. Right. So it says click. Let me just put it aside. Click 17.16.32.31.2. This one, right? Click it. Now I'm gonna put it aside here. Right. Open the command prompt. So I'm gonna open it. Desktop, command prompt. Right. So we are at the command prompt of 172.16.31.2. Okay, I do apologize if you hear some noises. Okay, can you guys hear me? There's some noise.
Can
yeah, the noise is from the neighbor doing some kind of renovation, drilling something. Yeah, sorry about the noise. All right, so we are here. We need to type ARP-D. So again, I said this command will basically empty out the entries inside this computer's ARP table. So it will not be able to know what is the MAC address of, if you start to communicate with any computer within this same network as this computer, you will not be able to find a match inside its ARP table because we have deleted the contents. Yeah, ARP-D. Okay, so if I look at the content, no entry. Okay, no entry found. So this ensure when we try to communicate, ARP requests definitely will be sent out. Okay. Now, please take note of the movement of the ARP packet. Okay. You will be able to see that it's because, as I mentioned before, from the theory, ARP requests will be broadcast one to all. So the switch will, since our LAN, okay, our LAN where 172.16.31.2 resides, has two other hosts only. So you can see that the ARP request should flow, okay, to flow to the other two, because the switch will follow our request to broadcast it, and we broadcast because we don't know the MAC address of destination, right? So whenever you are doing this packet tracer, this packet tracer exercises allows you to basically work out the theory we learned in class. So then you can see how it's implemented, okay, within the simulator. All right, enter simulation mode. So we go back here, right? Simulation mode, as we seen yesterday. Just click on the tab called simulation here, and the thing that's happening is that this will appear, the simulation panel. Now again, if you want to step through the simulation, you should click on that, right? And by default, you can see this filter, event list filter. It will list all of this. Let me click that. All of this available protocol for IP version 4 or IP version 6, and also other miscellaneous protocol. Now, if you just want to see a specific protocol, because what happens is if you click the checkbox and it's a tick, yeah, means you're telling the simulator you want to capture those protocols, those kind of PDUs, right? So it's up to you. If you just want to see ARP, for example, you just untick the rest. Okay, but for me, I just leave it as it is, right? So what happens is, as you start the simulator, it will actually capture, and the events list captured based on the time it was captured will be list out now, right? And you can, if you didn't use a filter, you can view the type of PDU to allow you. Let me just open it again. You can drag this, make it bigger, right? You can then select which PDU you want to view at which point it was captured, right? And then this gives you a better understanding about what is the content of the header, whether you're looking at the Ethernet frame or the network layer, and so on. But here we are interested in the network layer and the frame, right? Frame for its MAC addresses, okay, source destination, and network layer for its IP address. Okay, so let's go back to here and follow through. It says enter simulation mode, enter the command. So here at the command prompt, we want to generate a message. We're trying to ping. Okay, but this ping, as usual, when it comes to the frame layer, we need the frame layer, the data link layer needs to basically encapsulate the PDU, right? So the encapsulation process will need to have the MAC address, both source and destination. Since we don't know the destination, right, it will generate a ARP request before it can actually complete the ping. Okay, because for the ping to work properly, the ping also needs to not only the IP address we type, but also needs to have the destination MAC address. So before the ping can be performed, ARP requests have to be sent out first. Get the ARP reply back, and then from the ARP reply, we can get the MAC address, and we put the MAC address as destination MAC address. So you will see this process being simulated. Okay, the ping command cannot complete the ICMP packet without knowing the MAC address of the destination. Why it doesn't know? Because we already deleted the ARP table. So the computer sends an ARP broadcast frame to find the MAC address of the destination. Now the thing is, when it successfully received the ARP request with the ARP reply, I want you guys to, if it's not mentioned here, oh yeah, it's mentioned here. So I want you guys later to examine the ARP table. Do again, because now we do, there's no entries. Later, if it's successful, see whether there is an entry or not. This is the fact that the ARP will be dynamically updating the ARP table for you. Okay? Right, so the next step you need to do is click capture forward once. Okay, so you know it's not ping because ping cannot proceed because don't have the destination MAC address. So you'll see that ARP PDU will be generated instead from your computer, and then move to switch 1, right? And then just trace it. And then as you trace the movement, please take note and answer the questions here. Okay, is the address list listed in the table above? Okay, because you open the PDU, okay, and record the destination MAC address. See what is it? Is it listed in the table above, the address list table up here? Right? Is it listed there? Right. So then you can proceed. Okay, let me just click this. Proceed to do to go to switch 0. Sorry, not that. It's not that one. That's part 2. Okay. So here, right? E, open the PDU, examine layer 2. Okay, because you see, there will be one that is the accept will be tick. Do not accept as before is will be across. Okay, because it's a ARP request is a broadcast frame. Yeah. So okay, what is the IP address of the device that accepted the PDU? Okay, check it out. By theory, it should be this one, right? This one, because we put the ARP know that we want this IP address as MAC address. So it should be. So just confirm, confirm yourself. So what happened to the source and destination MAC addresses? Check it out in the PDU. And then click capture forward until PDU returns to back to your original PC. Okay. How many copies of the PDU did the switch make during the ARP reply? Okay, during the ARP reply means there's a reply back. Okay. Right. Once you finish that, you finish answering, go to step 2 to examine the ARP table. Do that. ARP-A. Okay. So basically, when you receive the ARP reply at your original computer, that will be updated, and you can now complete the ping. So you can see here it says ICMP packet reappears. Check its MAC address. Does it match? Means that is the one, the computer you want to ping really have that MAC address in the destination for the ICMP packet. ICMP basically the protocol for ping, yeah. And then once you take note of that, click back real-time tab, and this will allow the ping to move forward in a normal speed. Then go to check ARP-A. Okay. To what IP address does the MAC address entry correspond? In general, when does an end device issue? And here is conclusion from view. In general, when does an end device issue an ARP request? All right, so you can start off the process by clicking capture forward. Oh, what is NDP? Okay, NDP is, no, this is not part of our what, right? So we should be capturing only ARP and ICMP. Okay, never mind that one. Let me just go back to the ping. Oh, all right. This is a different process already. We don't, so reset this. Reset it, and let's go and do that again. In fact, I haven't pressed enter. So ping. All right. As you can see, immediately our host has this one. We want to create SCMP, but it's being paused because it cannot complete. Right. So right, there's no layer 2. Cannot create layer 2 frame. because we don't have the destination MAC address. Okay, so click on ARP. Remember the theory we learned? ARP request, because we don't know the destination, it has to be broadcast. And what is the broadcast address? Take note in layer 2. It's all F, right? So it matches our theory that the broadcast message will be all F. And what is the source? Source is this one, right? And if you check 172.16.31.2, you'll know that that is our MAC address. Okay, so this is what you need to do. As you click forward, it moves segment by segment. Please look at the content. Click the PDU, look at the content. As I said before, try to answer a question. All right, so I leave it there, part 1, and I want you guys to do the remaining parts of part 1 yourself so that you can answer the question. Is that okay? You know how to proceed now for part 1?
Okay.
Okay. Right, so I'm going to go now to part 2. In part 2, we want to examine a switch MAC address table. All right, so I need to, reset my simulation because I want to continue on this one. Yeah. So generate additional traffic to populate the switch MAC address table. So the switch is there. This is the switch because we are still working in this LAN, and the switch MAC address table, as I said earlier on, it's a mapping between ports and MAC address. So that means this port here that leads to this computer should be mapped to this computer's MAC address. This second port to this computer's MAC address, and the third port to this MAC address. Fourth port here should be matched to what? This interface, router interface, MAC address. Okay, so any active ports will have an entry in the switch MAC address table. Okay, right. So again, click on that computer, enter the ping command, and click 10.10.10.2. This one, another host in different LAN. Okay, and open the command prompt. Okay, right. So after that, enter ping in 10.10.10.2. Enter ping 10.10.10.3. So ping from one laptop to another laptop, and check how many replies were sent and received. Okay, so this one in this LAN. In this LAN, this computer ping this one. On this LAN, this laptop ping this laptop. Okay, so and then check how many replies were sent and received. Okay, replies of the ping LAN. Then examine step 2. We want to examine MAC address table on the switches. Click switch 1. Then the CLI tab. Enter the show MAC address table. So for that, show MAC. Right. So what you're asking the switch to do is show its MAC address table. Oh, sorry. Oh. right? So it seems like the switch MAC address table is all populated already. Okay, if the destination address of the inbound frame it sees is this, then it should be forwarded to this port, and so on. Right? Okay. The question say, do the entries in the switch correspond to the table in above, which is this one? Right? You make a comparison and answer. Right? And then do the same for switch 0. Switch 0 is on the other LAN. Do the same command and check its MAC address table whether it corresponds also. Right? Okay, it says here, do the entries correspond to those in the table above? Why are 2 MAC addresses associated with 1 port? Okay, if you do this, then go to CLI, go there, and show MAC address table. Right, so here you can see 2 separate MAC address. Find out which one is it from the table. Is associated to the same port. What does it mean? That's what here. This question. Why are 2 MAC addresses associated with 1 port? Okay. Okay. Answer that. And then part 3. Move to part 3. Examine ARP process in remote. So just now we checked the ARP process from this computer to another computer inside this LAN. So now we want to do between LANs, remote. Again, click this computer, open the command prompt, enter ping. Now we want to ping 10, 10, 10, 10, 10, 1. Okay, so here's 2 and 3. Let me just check which one is 10, 10, 10, 1. So it's not listed. So I suspect it could be this router IP address, right? So you can check. Go to that router, click on the CLI, and type show IP interface brief. Then you can see the router's interfaces. There are 2 interfaces here, and see whether what IP address is assigned. Okay, you know the command already from yesterday. Okay, but anyway, you enter the ping command. Type ARP-A. What is the IP address of the new ARP table entry? From here. Okay, type this. Let it run. Type this. Then you can check. Okay, what's the content of the ARP table now? Okay, again, after you take note of it, write down your answer. Enter ARPD to clear your ARP table and go to simulation mode. Repeat this ping. How many PDUs appear here? When you forward, click forward or capture forward, right? And you will see that when the PDU is at the switch 1, that means you have to let it run, right? Run to switch 1. So if it's at switch 1, click the PDU, see the target, that means the destination IP. Okay, you mean check it out and see what is the address. The destination IP address is not this. When you check this one, Why? Right? Okay, so that's what you're trying to investigate and find out. Examine the ARP table on router 1. Okay, switch to real-time mode, click router 1, click the clear tab. You want to go and check out inside router 1. Enter privilege exec mode, enable or can show MAC address table for router 1. How many MAC addresses are in the table and why? And then inside the router, show ARP. That's a command to show the ARP table in a router. Show ARP. Is there an entry for this? Inside the router, ARP table. Then answer this question. What happens to the first ping in a situation where the router responds to the ARP request? Okay? All right. So I'll let you do for that one, investigate. You can actually see what's happened to the ping. Right? Any questions on this one? No, because you guys have to go through it and step by step. Don't miss any step. Step by step. Okay. And don't skip to those straight away to part 2 or part 3. Do complete the part 1, answer the questions requested, and do part 2, answer the question requested, because the knowledge you gain there will add on, yeah. Will add on to your knowledge until you finish part 3. Okay, just remember what you're doing here. What's the objective is? You want to know more about the ARP request, whether it's in the same LAN or it's over to another LAN. Okay, so how does this ARP process helps the computer to get the MAC address? Because it's supposed to be automated, right? And at the same time, you will notice, okay, how the switch is actually working with the switch MAC address table. These are two separate things. Don't confuse them. ARP table is meant for the host so that the host know, okay, if I want to send a message to this IP address, where can I get the MAC address? Okay, that's ARP. Whereas the switch maintains its switching table so that it knows if it receives an inbound frame, it knows how to forward it out to which port. Which port should I forward this frame to? So it will check its own switch MAC address table. Okay, so for the switch MAC address table, what you need to understand is how does the switch updates its MAC address table, because the switch MAC address table can also be wiped out. Okay, could be reset. So how does the switch learn to create this switch MAC address table? Okay, that's for the switch. And how the switch uses the switch MAC address table to forward frames. Okay, how does it know which port to forward to? So that is one topic that you need to understand, how the switch works. And the other topic is ARP. ARP concerns, okay, I want to send a message in the LAN to that PC, but that PC I only know is IP. So we know we need both IP and MAC, the destination. So how can we get the MAC address if we only know the IP address? So that's where ARP comes in, the ARP process. So this exercise allows you to understand more how does ARP works, right? Okay. And the second ARP context that you need to learn is, if I want to send a message not into a computer in my own LAN to another computer in another LAN, so how does ARP works with that? Okay, think about it. do I really need to know? Because in my own LAN, I need to know the destination MAC address. Because in my own LAN, I know MAC address, although I need to supply my IP address, I mean the IP address, but I know the switch work with MAC address. But between my LAN, another LAN, which is remote, I know IP address is being used by the router. But what about MAC address? Do I need to know the remote computer's MAC address? On the theory, actually you only need the IP address, and the MAC address will change, right? So which MAC address should we use? So that part, the third part, is actually allowing you to understand that examining the ARP process in remote communication. Okay. All right. So I'll leave you guys to do this part. If you have any question, don't hesitate to ask. All right. Okay. So I go to the next packet tracer activity that you need to do. By the way, you guys have any time to do the yesterday's packet tracer activity?
Yeah.
Yeah. Successful? Okay. No hiccups?
Yeah, 100%. Yeah,
100%. Oh, good. Excellent. All right. So, okay, the next packet tracer is 10.1.4, configuring initial router settings. Right. So this is where we learn how to do basic configuration on the router. Now, remember, we already learned how to configure switch. Okay, this one is a router. Okay, so with this one, the router connects network together. So that means certain configuration remain the same. Okay, so the basic ones. Okay, but I think there are other settings that can be done on the router, because the router is actually performed differently than a switch. Okay, but majority of the other configuration, the more advanced configuration for router, you guys will only learn in your next course. Next course is a course, computer network course. So, but we just look at at least we know how to configure the router in order to make it work to forward any messages from one LAN to another LAN. Okay. So all those other complex scenario we don't cover yet. Right. So in this activity, we'll look at three. We want to verify the default router configuration. Then we want to configure and verify initial router configuration. So this is basically the basic things, like the basic things we learn about the switch, to configure it, we want to configure on the router. So some of the commands are very similar. Then we want to save our configuration. Okay. Right. So what are the configuration? Similar to the switch one. So if you've done the switch one, this one should be very easy for you. You will secure access to the CLI and console port using encrypted and plain text password. Right. So at the end of this, you should know how to do this. It will be assumed that you know how to do this. If you ask to do it, you should already know how to do the secret password or whatever, right? You also configure message for users. This is a banner message, MOTD, login to the router. This banner, when one unauthorized users are access prohibited. Finally, you will verify and set your running config. So basically very similar, right? So I'm just going to go very quickly. Establish a console connection to R1. Choose console cable. Click the PCA, select RS232. We know console cable is a communication cable, right? Serial cable, serial cable. Then click onto the router, select console port. Okay, and then you go to the PCA, desktop, terminal, and then perform the necessary. Then you can actually access the router CLI. I think this one is disabled if you go direct. Yeah. Okay, disable. So go here, click console, click here, select RS232. As usual, similar way for router and switch. Okay, so like you connected. Okay, in real world, this means you have to be physically there with the router. Okay, so normally we do this only for the initial configuration of router before we place the router inside like a server room or rack room, things like that, where we lock the room. Okay, so and for that later on, you normally will configure the router or switch via network. Okay, so oh, this is computer. So yeah, we go to computer, go to desktop, go to terminal, accept this default, click OK. You're basically looking at the router clear already. Enable, go to privilege mode. Okay, and then you just follow this configuration. Right, enable, you go in there inside the router privilege mode. Show running config will show you what's the current configuration of the router, and answer this. What is the router's host name? How many, based on the show running config, yeah? Or how many fast Ethernet interface? How many gigabit Ethernet interface? How many serial interface? Okay. For the VTY lines, what is the range of values shown? Right. Then display the startup config. Remember, startup config is created by you. Once you have the running config configured already, normally you set a copy running config, startup config. Of course, you haven't saved anything, right? So it's not present. Okay, right. Answer the question. Then reconfigure and verify the router configuration. Here means you want to provide password Cisco, and then encrypted, it's a secret, and console password let me in. Right. So why is it not shown step by step? Because you've done this in the switch already. It's the same commands for the switch and the router. So if you cannot remember, you can open up back your the switch exercise where you did this and follow exactly the same command. Right? Okay. Verify the initial settings by viewing the configuration for R1. What command do you use? The same command as before, right? So red dot command. Exit the current console session until you see the following message. That means you go all the way out, exit. Right? Press enter to get started. Unauthorized access is prohibited. Meaning to say, because you already configured this one, right? Message of the day. Enter the password and answer this. This one is more like a management question. Why should router have a message of the day banner? Okay, so what's the point of you putting in those messages basically? Okay, if you're not prompted for password before reaching the user exec prompt, what console line command did you forget to configure? Which one do you think? There are three password here. Which one was it? Okay, answer that question. Enter the password necessary to return to privileged access mode, which what we have entered. Why would the enable secret password allow access to the privileged exit mode and the enable password no longer valid? Okay, answer this question. If you configure any more password to the router, are they displayed in the configuration file as plain text or encrypted form? Explain. Okay. Right now, because recall our conversation with the switch last time. plain text can be seen, right? So we encrypt it. Now, after you encrypt it, if you configure an animal password, will they be shown as plain text or encrypted? If you're not sure, try, right? And then save the running configuration means just well, you know, right? Copy running config, startup config, right? Oh, I don't mind to tell you that. Right. So what is the shortest unambiguous version means? It's very long. Okay. Copy running config, startup config. What is the shortest you can make? Because remember, we always do shortcut nowadays, right? So for example, if here, if I want to go config terminal, now I know I can just type that configure terminal, right? Because as long as there's no ambiguity, there's no other command starting with C or NF, then I'm okay, right? So for copy running config, startup config, what is the shortest version? You try it out, right? Which one? You try to shorten until no more error. Sorry, until as long as no error, you shorten it until you get error. Then you know the previous one was the shortest you can do, right? Answer that question. And then save the startup configuration file to flash. Okay. Show flash. Let me see here if I have show flash. Oh, typo. Right. So this is my content of my flash memory. Okay. How many files are currently stored in flash? Which of these files do you guess is the iOS image? iOS is our operating system, right? So have a look at the content of the flash memory. Can you identify which of the file is the iOS image? And explain why do you think that is the iOS image, right? Then we want to copy the startup config from NVRAM to flash, right? Then you type show flash again, just in case there's a that is a backup lah. Just in case someone overwrites your startup config, or you yourself overwrite your startup config, right? So you have another place which is the flash. So the flash is basically like I think the technology works like a flash drive lah. That's why it's called flash. Okay. NVRAM is different. It's a non-volatile memory. It doesn't require electricity as well to maintain its storage, but it's a different kind of storage to flash in terms of technology. So a flash is a good way to keep permanently your file as a backup inside the device itself, right? So complete this. I think this one is should be very straightforward to you if you've done the switch one. Right? Any question? I'll stop here presenting. I want you guys can continue and do.